today we are doing, I don't have a better way of saying this than differential equation mop-up, okay? As I was looking through the test, there were a couple questions that kept popping up on the AP exam that I felt like we needed to go over. In reality, I don't need to teach you anything here. You can do both of these problems today, both types, by just looking at it and thinking about it. I don't have to teach you anything, but I want you to try it once and then see if I can help you clear something up. So that's kind of the goal today. The first set of questions here are all about proportionality. Okay, yesterday we talked about just rates being proportional to the cost, or the rates being proportional, whatever, and it was just always K times Y. These are just slightly different situations. So what I want you to do on that first one, read it with your neighbor, see if it makes any sense, and try to figure out the multiple choice answer, A, B, C, or D. Try to figure out what situation is it describing, then we'll go over it. Here we go. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you get? All right, so you needed my help here a little bit. That's good to know. We got 1s and 2s, which is good. I heard a few people talk about how did we know that it was going to be a negative rate? Water's leaking. And so it makes sense that if water's leaking, my rate needs to be negative. And so we eliminated C and D right from the start because it's leaking. All right. And then it talked about the rate of change of the volume with respect to time. So it is dV over dt. That's what that is describing. Is proportional, and so that means K, it's some constant, times the cube of the volume. Well, which one, A or B, is talking about the cube of the volume? B, right there, it says V cubed. Cube of the volume, V cubed, it's B. Don't overthink it. It's pretty straightforward. Makes sense on the first one. Try the next one. Here we go, 1 for A, 2 for B, 3 for C, 4 for D. We got some 2s and 4s. Let's figure out which one it is. 2s and 4s. Hard-boiled egg is removed from a pot of hot water and set on the table to cool. The rate of change of the egg's temperature T with respect to time T. So this is annoying. That's probably the most annoying thing about this. They use capital T to represent temperature and lowercase t to represent time. And the room temperature of 75 degrees. Which of the following is a differential equation that describes a relationship where K is constant? Okay. It says it's proportional to the difference between the egg's temperature and the room's temperature. So proportional, that means K, to the difference between egg temperature and room temperature. What does difference mean? Subtract. It's proportional. So K times the difference between the room's temperature and the egg's temperature. So which one are we picking here? D. We want D because we want to multiply times that difference. It's proportional to the whole thing there. Okay, one last one. Try example 3. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. This one's the toughest one, and we did the best on this one. Out of a total number N students, so N is the total number of students. The number of students have seen the program and who have not. S denotes the number of people who have seen the program, which the following differential equations could model this. And so it says increases at a rate proportional to the product of the number of students who have seen the program and the number of students who have not seen the program. So proportional, we got K. Product, so two things being multiplied together. So it's not A, because two things are not being multiplied together besides just a proportionality. We want to know the number of students who have seen the program, so that's S. How do we figure out the number of people who haven't seen it? Total students minus people who have seen it. That is where we're getting C from. S represents the people who have seen it, and then N minus S is going to represent the number of people who haven't seen it because it's total number minus S. Make sense on those problems? They're weird. It's not really calculus. It's just thinking about stuff. Okay. Example 4, this one's a little bit tougher. I wasn't going to show you any examples of this, and then I thought that was kind of mean. Because these are problems, at first glance, look super hard. And then second glance, it's like, oh, I just have to do it. Okay. To be honest, they're not really differential equations. We could throw these in back in in November, and you could totally do these at the same time. And so it's not a lot of differentials, at least in terms of how we're going to do them. Which of the following is a solution to this differential equation? Okay, so this is a differential equation because it has derivatives in it and it's got an equal sign. We want to know which one of these y equations would make that statement true. Xy prime minus 3y is equal to 6. And there might be some great ways of solving that. Here is the best way to do it. Use your multiple choice answers to try to figure it out. Okay, it might take a second, but we can do it. So we are eventually going to plug into this equation and see which one makes it true. For letter A, they told me y. What else do I need in order to use that equation? The derivative. I need to know y prime. What is y prime going to be for that first problem? 2x. Makes sense how I got that? And then I don't know if there's a much better way of doing this problem than just plugging it in. And so I'm going to plug into this differential equation with this given information and see if it's equal to 6. If it's equal to 6, I win. If it's not equal to 6, I don't win. And I got to do another one. Okay? So, for example, we are doing x. So I'm going to write down x times y prime. Well, y prime is this guy. 2x minus 3 times y. What am I going to put for y? X squared plus 2. And when I multiply that whole thing out, I'm trying to see, is that 6? Bless you. So I'm just going to do it. X times 2x. Well, that's 2x squared minus 3x squared minus 6. Is that 6? No, that's garbage. Don't pick A. Kind of makes sense how we're doing it. It's not anything fancy. It's just do it. Try B, C, and D. See if you can find an answer. If we're doing letter C here, I get y prime is equal to 75x squared. So when I plug that in, 75x squared minus, it's 15, duh. It's not 75. Where did you get that weird number from? Minus, then we've got 3 times y, so 3 times 5x cubed minus 2. This is going to get me 15x cubed minus 15x cubed plus 6. Is that equal to 6? Yeah, because those two things cancel. 6 equals 6. The answer is C. Makes sense on how to do it. Don't be weirded out. Just do it. Let's try one more. Let's go down. Let's try 5. See if you can do 5 there. 1 for A, 2 for B, 3 for C, 4 for D. What you get? All right. Be careful here. We didn't do perfect on that. Looking at this thing, okay, I'm going to do y prime. Make sure you took derivatives correctly. So I did the 3 sine 2x one first. The derivative of 3 sine 2x, I took the derivative sign, which was cosine. I rewrote the baby and then multiplied by the derivative of the baby. That's where I'm getting 6 from. And then I took the second derivative. And so the derivative of cosine is sine with a negative sign. Rewrote the baby times the derivative of the baby. That's why it's 12. But it makes sense on how I did the first part. Then we're going to plug that in. It says 4 times y plus y double prime. Guess what happens? It gets you 0. So 1 works. If 1 works, it can't be B or C. So I don't even need to check 3. Okay, because 3 isn't going to work because it's not one of my options. The only other one I really need to check is 2. And so I did the same thing. Y prime was negative 10 sine 2x. Y double prime is negative 20 cosine 2x. Then I'm just going to plug it in. And so it's 4 times 5 cosine 2x. That's a 5, I swear. 5 cosine 2x minus y double prime. So minus 20 cosine 2x. When I multiply there, it's going to get me 0. It's D. Questions on how we do those? There's not a great category to what type of questions these fall into. They call them differential equations. This technically is a differential equation, but we didn't do any integrations. All we did was just kind of work through the multiple choice answers. If you need some more practice, example 6 is a good one to go to as well. I think we're